Phosphorus is found in many allotropic forms, and the important ones are white, red, and black. So here the white phosphorus is very first allotropic forms, which is a waxy solid, insoluble in water, and having an important property of chemiluminescence. When it dissolves in boiling NaOH in inert atmosphere, it forms phosphine, which is again another compound of phosphorus. So phosphine is being formed by heating white phosphorus in NaOH, and along with that sodium hypophosphite is also formed. White phosphorus is less soluble, that is why it is more reactive than other forms. And the normal conditions, its structure is having the bond angles at 60 degree. It readily catches fire and forms dense fumes of phosphorus oxide. So here we can say it is more reactive than other form. Easily it reacts. Reason is that its structure means its strain structure, which is having the weak bonding, the bond angles are 60 degree, so that is why it is considered to be a strain structure, and that easily decomposes in air to give wide dense fumes of phosphorus oxide. It consists of tetrahedral structure as shown in the diagram. So here coming to the another allotropic form of phosphorus, that is red phosphorus. So red phosphorus is being prepared by heating white phosphorus at 573 Kelvin temperature in the inert atmosphere. So we can say that white phosphorus can be used to prepare red phosphorus, and when red phosphorus is being heated, it is used to prepare the black phosphorus. Now red phosphorus is having irony gray luster, and it is also insoluble in water but non-poisonous in nature, and red phosphorus is less reactive than white phosphorus and do not glow in dark. So chemiluminescence is only shown by white phosphorus. Now as we can see the structure also of red phosphorus, which is a linear structure in which all the tetrahedral units are linked together and slightly more stable than white phosphorus. Black phosphorus has two forms, that alpha and beta forms. Alpha form is being formed when red phosphorus is being heated and in a sealed tube at 803 Kelvin. Then the rhombohedral crystals is also being formed. It do not oxidizes in water or in any air. Why? Because it is the most stable structure. Now coming to the very important compound of phosphorus, which is phosphine. The general formula is pH 3. It has been prepared by heating calcium phosphide with water or with dilute HCl. So here when calcium phosphide is heated with water, it gives calcium hydroxide and phosphine, as well as when calcium phosphide is being treated with dilute hydrochloric acid, it gives calcium chloride and phosphine. We can also prepare it in lab, as we have already discussed just now, by heating white phosphorus with concentrated NaOH, and in an inert atmosphere of CO2, it gives phosphine and sodium hypophosphite. When it is pure, it is non-inflammable but becomes inflammable in presence of P4 vapors, which is normally present in P2H4 form. Now, on treating with KOH, it is also being purified when it has been absorbed in HI to form phosphonium iodide, which on treating with KOH gives phosphine. Now coming to the general properties of phosphine, it is colorless and gives rotten egg-like smell, highly poisonous. Means phosphine is not good, it is highly poisonous, and it explodes when it comes in contact with oxidizing agents like HNO3, Cl2 and bromine vapors. It is slightly soluble in water. The phosphine in water decomposes to give red phosphorus and hydrogen. It is very important to note that when the solution of phosphine in water decomposes in presence of light, it gives red phosphorus and hydrogen. But when absorbed in copper chloride and mercurous chloride solution, the corresponding phosphides has been formed, which is shown in the reaction. That copper sulfate, when treated with phosphine, it gives copper phosphide and sulfuric acid. Mercury chloride, when treated with phosphine, it gives mercury phosphide and HCl. Phosphine is weakly basic like ammonia and gives phosphonium ion. Means this gives the nature of phosphine, that it is also basic in nature. When reacts with HBr, it gives the salt. Now coming to the uses, which is very important, it is used in the home signal. Now what is home signal? Calcium phosphide is being treated with water and it creates smoke when combusted in air to give a home signal. Containers containing calcium carbide and calcium sulfide are pierced through the sea, thrown in the sea. When gas evolve, it gives burning signal and served as smoke screen. Once again I am explaining this. The home signals, the spontaneous combustion of phosphine gives the vapors of P4O10, the fumes, which is considered to be home signal as a covering gas. Now it is also being used as smoke screens in sea voyages. There is a container in the ship containing calcium carbide and calcium phosphide, which it can comes in contact with seawater. The gas is being released, which gives a burning red signal